Hi there. Here I'd like to demonstrate how I can swap the power source on this Unimat 3 lathe from its 2-speed 240 volt AC motor to a variable speed 24 volt DC motor. I aim to provide enough information for you to follow a similar path should you wish to be able to continue using your Unimat in the event of any motor failure. By the way, I'm firmly entrenched with the idea of keeping my original belt drive system, even though being able to alter drive ratios becomes redundant once the variable speed motor is fitted. Having this lathe looking original and being able to convert it back to its original motor at any time are both matters of high importance to me. Please watch as I remove the original motor and set up the scooter motor. First, I'm showing the original motor that I've repaired since it failed on me, running on each of its 2 speed settings. Now I'm unplugging it and removing the drive belts. At this point, it becomes easier to proceed with the drive assembly removed from the lathe. Excuse my constant fumbling, perhaps I should have rehearsed all this beforehand. Now I'm removing the screws securing the motor pulleys. Sliding off that pulley and removing the drive pin. And now I'm removing the 2 motor securing screws. Twisting the motor moves the last screw to a more accessible position for removal. That's my old Unimat motor now removed. Notice how the new 150 watt DC motor is so much smaller than the lower powered original. This gives me a few millimeters extra in swing because, unlike before, the work will now hit the bed before it will hit the motor. Here I'm trying to remember which of the 3 mounting screws I need to fit first. It's got to be the one that gets almost hidden under the idler pulley. Notice how I machined a 24mm boss into the front plate of the motor. Without this, I'd be fumbling around even more trying to centralize the motor around the mounting plate hole. Incidentally, when extracting that front plate off the motor in order to machine it, I was surprised to find the motor brushes were at the front and were coming off with it. They slid off the commutator easy enough, but then they had to be gently lifted over the front bearing, which was still locked onto the rotor. Somehow I managed to get the cover back in place. To do so, I forced the brushes right back into their holders and temporarily held them there with pieces of cotton thread. Cutting away that thread and making the front cover back in place was a little tricky to say the least. but it was well worth the effort in my opinion. It's nice to have 3 mounting screws rather than just the 2 of the original motor. It makes the mounting feel so much more secure. I machined up a completely new pulley for the scooter motor. While the rotor shafts are both 8mm, I wanted to have an extended boss at the rear of this one to fit a grub screw into and to make maximum use of the rather short output shaft I've been given. Needless to say, the pulley's other dimensions match those of the original. By the way, I drilled an indent in the shaft for the grub screw to ensure the pulley will always end up in the exact same location. You can see me here making sure I've located it before tightening. And now I'm refitting the drive assembly and locking it in place with my 10mm spanner. Now I've turned the Unimat around so you're seeing it from the rear. And here I am connecting the speed controller. And now I'm connecting in the 200 watt DC power supply that I understand was manufactured to power LED strip lighting. I think it'll do a fine job of powering my 150 watt scooter motor. Now I'm grabbing the speed controller. Notice how the dial has an on-off switch incorporated into the start of its movement. This is the way I'll be turning my lathe off and on whenever the scooter motor is fitted. In this way, starting and stopping will always be gentle. Here I am, gripping the chuck quite hard with my fingers to prove it won't just stall. It delivers full power at almost any speed I care to set the dial to. Here I am switching the speed control, first to an off position and then to one providing rotation in the other direction. Now I'm removing the speed controller so I can demonstrate how the DC power supply can be linked directly to the motor. I don't imagine I'll ever want to run it this way, and that's why you see me disconnecting and reconnecting without bothering to turn off the power. I've simply not bothered to fit a conveniently located on-off switch for the process. I don't intend repeating it. Now here are some photos to provide further information and clarification. First we have the pitch circle diameter of the mounting screws on my original motor. Now here are the measurements provided by the vendor of my new motor. As it turns out, the 3 holes are conveniently located on the very same 42mm PCD. Thus, no modification of my existing mounting plate was necessary to mount this new motor. Here we have the new motor as it arrived to compare with my Unimat motor. And here I've removed the left-hand threaded nut in the sprocket. I was pleasantly surprised to find it came apart easily with no locking compound having been used. Now here is my new motor after I machined a 24mm boss into its front cover. That cover was only 2.8mm thick, so I couldn't make it very high. And here's a close-up view showing the indent I drilled in the shaft for the grub screw to bite into. And here are the motor brushes that I was so surprised to find coming off with the front cover. If you're having trouble reading the words on this picture, they're unimportant. You see, I write on many of my pictures for my own benefit. At the time, I didn't know I'd be showing this picture in a video on YouTube, where the video quality is often less than ideal. Here I am making my new pulley on my much larger Boxford lathe. My Unimat was out of action at the time due to motor damage that I've since repaired. And here's my new pulley alongside the original, and now showing the grub screw. Now that pulley is fitted to my new motor. And here is a short video showing how the rear of my new pulley actually penetrates into the hole in my mounting bracket. This creates maximum shaft engagement, which I think is important considering the short shaft length I have available. And here's a shot of the 200 watt 24 volt DC power supply I've chosen to use. And here is my speed controller exactly as it arrived. I needed to mount the dial and switch into the front face myself, but they were quite simple tasks. By the way, I'm rather a fussy person, so I was disappointed the heat sinks hadn't been mounted squarely on the circuit board. I used 2 pairs of these connectors in my leads. According to the specifications, they can each handle 14 amperes, and that's ample for this application. Here I am soldering the pins in place. I've always preferred soldering to crimping, and no doubt this gives you some insight into my age. Here are the new leads on my controller finished. And now I'll end with a brief chat about Unimat motor and spindle speeds. On a whim, as part of this work, I attempted to measure the speed of my original Unimat motor. I found this was futile. You see, the motor was revving beyond my meter's maximum reading capability of 4,000 RPM, and that's even on its slowest speed setting. Here I am measuring my lathe spindle speed with my belts in the BC2 belt position. I can measure this speed because it's far less due to the pulley ratios in use. What I found was that all the speeds quoted by the manufacturer, whether they be on the plates and stickers or in the instruction manual, and whether they be motor speeds or lathe spindle speeds, are nominal speeds. In other words, they're not real values, but instead are imaginary values that have been dreamed up by someone making an attempt to be helpful. My actual speeds are seldom even close to what's being claimed, and they always fluctuate widely because they're totally load dependent. On that note, I'd like to finish.